Hey guys, this is Coach Brian going over the 3.5 notes with you. 3.5 is about the angles formed when you have parallel lines that are transversed or cut through by a transversal line. And so to understand the angle theorems and postulates, it says refer to this diagram to see the relationships of the big and small angles. And so when we're talking about big and small angles, it's just kind of in reference to these letters right here, B and S, big and small. And so we're trying to look for the relationship between these. And so the first thing is you got to have parallel lines. So in this situation, A and B are parallel to each other, okay? And C is the line that is kind of cutting through them or slicing through them. And the way I like to think about it is that, this transversal is cutting through line A and it's cutting through line B, and it's got a slope for sure, and its slope isn't changing, and so the angle with which it cuts through line A is actually identical to how it cuts through B. So you can kind of think of these intersections as identical to each other, okay? Those intersections are identical to each other. And that helps us to understand the relationships of the angles at each of those intersections. So the first one we're going to look at is a corresponding angles postulate. And this says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Pairs of corresponding angles are congruent. Let me actually clean that up a little bit. That's better. All right. So what that means is, that the corresponding angles, it's kind of like, the one here is corresponding to this one right here. They're in a similar position at an identical intersection. And this one here is identical to this one. They are in the same location at matching intersections. And so that's what we mean by corresponding angles. Our next type of angle relationship is alternate interior angles. And this kind of has to do, the wording is very important here. Alternate means they are on opposite sides of the transversal, okay? So they're going to be on opposite sides of this cutting line, okay? And interior means they're actually going to be in between the parallel lines. So if I'm looking at, my image up here, interior is going to be, in the middle. Exterior is going to be outside. So they have to be on opposite sides of the line, in between the lines. And the kind of definition or rule for that is that if there are two parallel lines and they're cut by a transversal, the pairs of alternate interior angles are, again, congruent. So if we're looking here, these two angles, see how they're both inside the lines and they are on opposite sides of the transversal. Same thing with the small angles here. They're inside this region, okay? They're inside here, and they're on opposite sides of the line from each other. So those are alternate interior angles. As you might have guessed, alternate exterior angles are on opposite sides of the transversal. Okay, so they're going to be across the transversal from each other, which is C, if you don't remember. And then they're going to be exterior, which is going to be out here somewhere, okay, outside of the parallel lines. So as we're looking at those, you can see how this S right here, opposite side of the line, also outside that S, those are congruent angles. Those angles are identical measure. And you've got B out here, exterior, alternating that B down there. Those are equal to each other. They're congruent with one another. Next, we have same side interior angles. Same side interior angles. So, Again, it's kind of all in the name. They're on the same side of the transversal, and they are inside or in between the parallel lines in this region, and they're on the same side. So these pairs right here, those are same side interior angles, okay? And they are supplementary, not congruent. They're supplementary, and if you forgot what that means, it means they add up to 180 degrees. All right, so knowing these kind of rules, these postulates, these theorems, we're going to move on to example number 1. It says, use the diagram to find x and note that the arrows indicate that these lines are parallel. If you see this symbol right here, how it's on both of these lines, that means that those two lines are parallel. Okay, those two lines are parallel. And then what it's asking me to find is the value of x. Value of x. Well, if you look, okay, these are I'm just going to kind of highlight them right here. These are the parallel lines. That's a giant highlighter. Let's make that a little smaller. That's okay. And then here can I change the color? There we go. Here in blue, that's the transversal. Okay, that's the transversal. And so all these relationships are in reference to those parallel lines and that transversal. So if I look, 75, let me switch back to my pen. 75 right here and 15x, they're actually on the same side of the transversal. Now, are they both interior? No. Are they both exterior? No. This is interior. This is technically exterior, but they're in the same position as each other if you look at those two intersections. And because they're in the same position as each other, we would call those corresponding angles. Corresponding angles, like we defined in day 3.4 in our vocabulary. Corresponding angles on the same side and the same position. And because they're corresponding, we know they're actually equal to each other. And so we can set up an equation where 75 equals 15x. We would just divide both sides by 15, and x equals 25. X equals 25. There is, oh, wait, I'm sorry. I'm so sorry. X just equals 5. 25 is way too large. Sorry about that. If you ever check yourself, just plug your number back in as x and see what you get. 5 times 15 equals 75. So we know we are good right there. All right, so those were corresponding angles. If we look at example 2, similar type situation. Get our highlighter out here. Here's our transversal. And here are our parallel lines in green. So everything that we're talking about is in reference to those transversals and parallels. And so we've got these two angles right here. Right there and right there. And just like in the first example, they're on the same side. And they're in the same position as each other. So again, these are corresponding angles. And when you have corresponding angles, they are equal to each other. So you would just set their two equations equal to one another. And then I normally like to take the smaller x value, which in this case is 2, move it over, take it away from the larger x value. And then I would need to take this 30, negative 30, and add 30 to both sides. So I get 3x equals 90. I'm going to divide both sides by 3, and that would give me x equals 30. X equals 30 is my answer. All right, next we're going to be proving some things. Proof of the alternate interior angles theorem. So the very first thing we're given is that L is parallel to M. All right, that's what that little symbol right there means. It means they are parallel. So these two lines are parallel. And they are cut by a transversal line. So that means there's a lot of angle relationships that we can recognize here. But ultimately, what it wants us to prove is that angle 2 is congruent to angle 3. That's the final thing we're trying to prove, is that these two are equal. Well, we can start with what's given to us first. And what's given is that line L is parallel to line M. Let me make that actually look more like an L. Line L is parallel to line M. So that's given. That's, we understand that. And because these two lines are parallel, like I said, we know that these intersections are very similar. So similar, they're identical. So the first thing we want to start with is, what do we know? What can we figure out about these different angles? And the first thing is that 1 and 2 are across from each other at an intersection. And when two lines are across from each other at an intersection, we know that they are equal or congruent because of the definition of vertical angles. We know that vertical angles are across from each other at an intersection, and they're equal. And then we can actually go ahead and say that 1 and 3 are equal because they're same side corresponding angles. Angle 1 is congruent to angle 3 because they are corresponding angles. And lastly, since 1 equals 2 and 1 equals 3, okay, 2 equals 1, 3 equals, that means they equal each other. That is what we call the transitive property of congruence. Because they both equal the same thing, they must equal each other. Transitive property. All right, still moving. Example number 4 says, use the diagram to find x. So our unknown x is right down here in the parentheses. And we have two parallel lines. How do you know they're parallel? Because of the arrows. Because they're parallel, that means they have the same slope. They'll never cross, they'll never intersect. This is my transversal. So ultimately, if I'm looking at the relationship between these two angles, they are alternating because they're on different sides of the transversal, and they are exterior, alternating exterior. They're exterior because they're outside of the parallel line. They're not in this zone right here that I'm shading, okay? They're exterior, and they're alternating because they're on different sides of the transversal. So one thing we know from up here is that alternate exterior angles are congruent. Alternate exterior angles are congruent. So I know that 136 equals 4x. And so just to find x, I'm going to divide each side by 4. And 136 divided by 4 is 34. So that is my unknown value. Going down to 5, it says use the diagram to find x. Well, if you notice, both of these are on the interior, okay, between the parallel lines. They're also on the same side of the transversal. These are same side interior angles. If you go up here, same side interior angles are supplementary. That means they add up to 180 degrees. So these two right here are supplementary, which means when I combine them, 14x plus 12 plus 19x plus 36, they equal 180. So the first thing I need to do is combine like terms. The numbers with x's I'm going to put together, and so 19 plus 14 is 33x. And then I've got my whole numbers that don't have x's attached to them, and 12 plus 36 is 48. And again, that all equals 180. So I'm going to subtract 48 from both sides because I'm trying to isolate x. And I get that 33x equals 132. 132. My very next step, I'm going to write over here to the side where I've got more room. 33x equals 132. My final step is going to be divide each side by 33. X equals 4. On example 6, just to be clear, this is talking about this angle and this is talking about the one it's in. These angles are on opposite sides of the transversal, so they're alternate. And they are also in between the parallel lines. So not only are they alternate, they're also interior. Alternate interior angles. And the relationship between those alternate interior angles are congruent. That means they equal each other. So since they are congruent, we can set them equal to each other. To start solving, I like to take the smallest number that's attached to a variable and subtract it from the larger side. Just helps me keep positive numbers longer. And then I'm going to take the 150 and add it over. And so I've got 2y equals 110. Divide both sides by 2. Y equals 55. Y equals 55 degrees. All right, almost finished. Example 7. Example 7. It says to find the missing angles from this diagram and that A is parallel to B. These two lines, A is parallel to B. So the very first thing I start with is one known angle, 47 degrees up here. Well, there's lots of places I could start with this, tons of places I could start, okay? But let's actually just go in the order that they give us. So starting with angle 1, this is my situation right here. I've got two angles that are adjacent and they form a line. When angles are adjacent and they form a line, that's what we call a linear pair. And they add up to 180 degrees because they are also supplementary. So for angle 180, I'd have angle 1, I would have 180 minus 47, and that equals 133. And that's the angle of 133 degrees. Now, next on my list is angle 4. And if you look at angle 4, there's a couple of ways I could go about solving this. One, you could say that these two are adjacent and they form a line, which means they're also a linear pair, which means they also add up to 180. Or another way you could look at it is that angles 1 and 4 are vertical. And because of that, either way I calculated this, I should get that angle 4 is also 133 degrees. Angle 6 down here. If you look at angle 6, they're on the same side in the same position, which means they're corresponding. Corresponding angles are congruent. Angle 8 is down here. Well, angle 8 forms a linear pair with 6. Forms a linear pair with angle 6. I'll draw that in a different color just to make it a little. And we just said that angle 6 is 47 degrees. So if these two form a linear pair, that means angle 8 is 133 degrees. And if you look at it, it's also corresponding to angle 4, which is 133. And so, like I said, there's lots of ways to attack these problems. If you look at angle 3, it's vertical to our original angle. It also forms a linear pair with angle 1. So whichever way, it's 47 degrees. Angle 5, how could you look at it? You could say it's corresponding to angle 1. You could also say, because we already know angle 8, you could say it's vertical to angle 8. You could also say it forms a linear pair with angle 6. So lots of different ways we could go about this, but it is 133 degrees. And lastly, angle 7. All right, angle 7 corresponds to angle 3. So we know it's 47. Also, it forms a linear pair with 8. That means angle 7 plus 8 adds up to 180. And that gives us 47 degrees. Now, pretty interesting last one here. We have a couple of angles, 126 and 113. And so the fact that these are different lets you know that these two transversals have different slopes. Now, just like the question says, A and B are perpendicular. So we have some similarities between these and we have some differences. Okay, we have some similarities and some differences. The first thing we want to start with, let's just go in order. Find angle 1. Angle 1 forms a linear pair with 126. So 180 minus 126 equals 54 degrees. That's angle 1, 54 degrees. Now, angle 3 is opposite of our original angle. It's a vertical angle, which means it's congruent to, and it's also 126. Angle 5 over here forms a linear pair with 113. So 180 minus 113 equals 67. 67 degrees. Now, before we move to the bottom down here, let's do 2, 4, and 6. Angle 4 is vertical to angle 1, which means it's congruent. Angle 2 is a linear pair with 113 or is opposite vertical to angle 5, so it's also 67 degrees. And lastly, angle 6 is vertical to the 113, which means they're equal. All right, guys, moving down here to our remaining angles. We need to find 7, 8, 9, 10, 11, and 12. And I know that on yours there isn't a number 11, so just add in right there a little 11 because that's our missing angle. Sorry that got cut off. So there's a couple ways that we could approach this, okay? A couple ways that we could approach this. First one I want to point out is that 7, 8, and 9, okay? 7 plus angle 7 plus angle 8 plus angle 9. They make a line. So that means together they all equal 180 degrees. Also, 10, 11, and 12 also form a line. Angle 10, angle 11, and angle 12. They also add to 180 degrees. Another thing I kind of want to visually point out here is that angle 126 up here, this 126 degree angle. You see how 8 and 9 are corresponding to that? All right, so 8 and 9 together should also equal 126. And that means 10 and 11 together should, because they're vertical. And then the last thing I want to point out before we kind of get into it is that 8 and 7 together, all right, see how they're corresponding to this angle right here, 113. So 7 and 8 should equal 113. So you just have kind of a lot of visual references here. The first thing that I want to point out is that angle 2 up here that we said is 67 degrees is corresponding with angle 9. Corresponding angles are congruent, so that means that angle 9 is also 67 degrees. Angle 7 down here is corresponding with angle 1, which we said is 54 degrees. Corresponding angles are congruent, so angle 7 is also 54 degrees. And then angle 8 right here in the middle is the one we don't know, but we know a lot about it. We said that when it's combined with 9, it should equal 126. When it's combined with 8, it should equal 113. And when you add all three of them together, it should equal 180. So let's go with that 180. All right, we've got 180 degrees. 180 degrees. Let me just clean that up. 180 degrees minus angle 7, which is 54, and minus angle 9, which is 67 degrees. So when we calculate 180 minus 54 minus 67, we get a remainder of 59 degrees for angle 8, 59 degrees. And you could go ahead and test that with the rest of the things we said. Is 59 plus 67 126? Yeah, it is. Is 59 plus 54 113? Yes, it is. So all those things kind of, intertwine, and we're able to use all that information to not only determine what angle 8 is, but also to determine if our answer is right. And then the last thing we'll use here is just, vertical angles. 8 is across from or vertical to 11. That means they're congruent. Sorry, that's a very hard to see color. Angle 10 and 9 are vertical. That means they're congruent. So 10 and 9 are both 67 degrees. Angle 7 and 12 are vertical. So that means they're congruent. That means 12 is also 54 degrees. So hopefully through what you did on 3-4 and now how you've reinforced it on 3-5, these angle relationships are really making a lot more sense to you, and you're starting to see them a lot better when you're given examples and understand the relationships a lot better as well. Hopefully this helped, and I will also be sharing the practice with you soon.